Good morning. For this assignment, we'll be applying the properties that we've learned and using them to justify each step of our either our equations or our statements about line segments. Now up here we have the properties of equality. Notice at the top we have the arithmetic properties, and down here we have reflexive, symmetric, transitive, and substitution property. So we're going to first go through each of these. I'm going to summarize this assignment. So first, each time we solve something here, or change something here, we're going to write the property that we are applying. So for example, here, first I'm going to use the distributive property. I'm going to distribute the -2. So I have 2w minus 6 equals 15. And I applied the distributive property. So I just say that. I could say the distributive property, or I did. Next, we can add 6 to both sides. So we have 2w equals 21 because we added 6 to both sides. That's the addition property of equality. Write it right there. Next, we divide by 2. So w equals 21 over 2. And that's the division property of equality. So we say which property we use with each step just to make it clear that we're always using mathematical reasoning, right? Whenever we write something new, there's always a mathematical reason we can write it like that. So especially during geometry, we practice explaining that reasoning. So you're going to have a similar process. You're going to write the steps to solve these two equations for the variable. And then next to each step, you're going to have some sort of reasoning. Okay, that's with algebra. Down here, there's some more application. With this, you just state the property for each statement. For example, this first one, I'll just answer the first one. If JK equals PQ and PQ equals ST, then JK equals ST. What property is that? Well, they both equal PQ, so they're equal to each other. That's the transitive property of equality. And then we're going to go through each one, or you are, and going to describe what property seems to be used there, okay? So that's for algebra. Down here, notice I wrote some theorems, the properties of segment congruence. And so down here, there's some blanks for the reasons. You're just going to write the reason for each blank. Then there's these equations. So you have to solve for the equations. In each step, you have to solve for the equations, and then you have to use the given information to write some sort of equation. Can you put them equal to each other? Do you put them equal to another value? You sort of have to explain what properties you're using to get to your answer. So you have to do some reasoning there. But I'm going to show how you actually write a proof with this number 17 and this triangle. So you're told that xy is equal to 8. The measure of xy is 8. The measure of xz is also 8. We're also told that xy and zy are congruent. And we want to show xz and zy are also congruent. So I'm going to write out, I'm going to label this steps over here. And then over here, I'm going to have reason. So our first step, actually, is that correct? Oh, statement, right? There's statements, not steps. Statement. And then we have our reason. It's over here. So our first, I noticed that these both equal 8. This is sort of the logic I use while solving these. They both equal 8. So that means by the transitive property, I can put them equal to each other. So I'll start there. So xy equals 8. And xz equals 8. Right? So then And those are both given statements. So for the reason I just put given, right? Proofs start with given statements, and then you make conclusions. And then I can put those two equal to each other. xy equals xz based on the transitive property of equality. So to write a transitive property of equality, then I'm going to change that to a congruent symbol based on the definition of a congruency. I'm going to copy this. I'm going to put a congruency symbol, and I'm actually going to make sure it's the same font and everything. Oh, there we go. Okay, so xy and xz are congruent, and that's the definition of congruency, right? Then I notice xz, xy, and zy we're also told those are congruent. So I'm going to put that down. I'm actually going to copy this here and just rewrite the part that's rewritten. xy and zy are also congruent. And that's a given statement. Because I notice they're congruent to each other, or they're congruent to the same segment, so that must mean they're congruent to each other. And that's what we're trying to prove. So I write that out. Z is congruent to zy, and that is the transitive property, and its technical name is of segment congruency, right? Okay, so again, I noticed these two segments had the same measure, so I say they must be equal lengths, therefore they're congruent. Then I was told that these two are congruent. Since they're both congruent to x, y, they must be congruent to each other. And that's basically how we write a proof. So again, in this assignment, you're not going to write your own proof. However, probably later on, there'll be at least a few of them where you have to write them. But the main idea is being able to identify what properties are being used. We're just getting used to this idea of using properties, all right? Well, okay, so just go through this assignment. Make sure to ask if you have any questions during class or during tutoring or scheduling tutoring, or otherwise you can always email me if you have any questions or if you want me to check your assignment. Make sure you properly apply all the properties and theorems. Just do your best on it. I will talk to you next time. All right, have a good day.